First, concentration of bauxite ore. Bauxite is the main ore of aluminium. Silica, SiO2, ferric oxide, Fe2O3, and titanium oxide, TiO2, are the impurities present in bauxite. Separation of these impurities is done by leaching process using either Bayer's method or Hall's method. In both these methods, finally, the concentrated alumina is obtained by calcination. In the Bayer's process, the ore is first ground in a ball mill. Then it is leached by heating with concentrated solution of caustic soda, NaOH, at 140 to 150 degrees Celsius under high pressure for 2 to 8 hours in a digester. Aluminium oxide being amphoteric in nature, it reacts with the aqueous solution of sodium hydroxide to form water-soluble sodium aluminate. This means that bauxite is leached by sodium hydroxide solution. Al2O3 2H2O solid plus 2NaOH aqueous gives 2NaAlO2 aqueous plus 3H2O liquid. The iron oxide in the gangue does not dissolve in aqueous sodium hydroxide. It is separated by filtration. However, silica in the gangue dissolves in aqueous sodium hydroxide to form water-soluble sodium silicate. Aqueous sodium aluminate is diluted by putting in water and is cooled to 50 degrees Celsius. This results in precipitation of aluminium hydroxide. NaAlO2 plus 2H2O gives NaOH plus AlOH thrice. In the Hall's process, the ore is powdered and then leached by heating with aqueous sodium carbonate in the digester to form water-soluble sodium aluminate. Then, the insoluble impurities are filtered out. The filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of aluminium hydroxide. Al2O3 2H2O solid plus Na2CO3 aqueous gives 2NaAlO2 aqueous plus CO2 gas plus 2H2O liquid. 2NaAlO2 aqueous plus 3H2O plus CO2 gas gives 2AlOH thrice precipitate plus Na2CO3. The precipitate of AlOH thrice obtained in both Bayer's and Hall's processes is filtered, washed, dried, and then calcined by heating at 1000 degrees Celsius to obtain alumina. 2AlOH thrice gives Al2O3 plus 3H2O. Second, electrolytic reduction of alumina. A. In this method, electrolysis of molten mixture of alumina, whose melting point is more than 2000 degrees Celsius, is done in a steel tank. The tank has a graphite lining on the inner side. This lining does the work of a cathode. A set of graphite rods dipped in the molten electrolyte works as anode. Cryolite, Na3AlF6, and fluorspar, CaF2, are added in the mixture to lower its melting point up to 1000 degrees Celsius. B. Aluminium is deposited on the cathode on passing electric current. Molten aluminium, being heavier than the electrolyte, is collected at the bottom of the tank. It is taken out from there from time to time. Oxygen gas is liberated at the anode. The electrode reactions are as shown below. At anode, 2O2 minus gives out 4 electrons to get O2. This is an oxidation reaction. At cathode, Al3 plus ion gets 3 electrons and gives Al liquid. This is a reduction reaction. The liberated oxygen reacts with the anodes to form carbon dioxide gas. The anodes have to be changed from time to time as they get oxidized during the electrolysis of alumina. Extraction of moderately reactive metals. Can you tell? 1. What are the moderately reactive metals? 2. In which form do the moderately reactive metals occur in nature? The metals in the middle of the reactivity series, such as iron, zinc, lead, copper, are moderately reactive. Usually they occur in the form of their sulfide salts or carbonate. It is easier to obtain metals from their oxides rather than sulfides or carbonates. Therefore, the sulfide ores are strongly heated in air to transform them into oxides. This process is called roasting. Carbonate ores are strongly heated in a limited supply of air to transform them into oxides. This process is called calcination. The following reactions occur during roasting and calcination of zinc ore. Roasting, 2ZnS plus 3O2 gives 2ZnO plus 2SO2 gas. Calcination, ZnCO3 gives ZnO plus CO2 gas. The zinc oxide so obtained is reduced to zinc by using suitable reductant such as carbon. ZnO plus C gives Zn plus CO gas. Apart from carbon, reactive metals such as sodium, calcium, aluminium are also used as reducing agent for the reduction of metal oxide to obtain the metal. This is because these metals displace a moderately reactive metal from its compound. For example, when magnesium dioxide is ignited with aluminium powder, the following reaction takes place. 3MnO2 plus 4Al gives 3Mn plus 2Al2O3 plus heat. Identify the substances undergone oxidation and reduction in this reaction. The heat evolved in the above reaction is so large that the metal is formed in the molten state. Another similar example is the thermit reaction. Here, iron oxide reacts with aluminium to form iron and aluminium oxide. Fe2O3 plus 2Al gives 2Fe plus Al2O3 plus heat. Do you know thermite welding method used for welding rails? Thermite welding is a liquid state chemical welding process in which joint formation takes place in molten state. In this process, The molten iron is poured at the welding plates and solidifying is allowed to make a permanent strong joint. In this type of welding, a mixture of aluminium and iron oxide is used in ratio 1:3 by weight. This reaction gives aluminium oxide and iron and also liberates a huge amount of heat, which converts this mixture into molten state. Because the molten iron has higher density compared to aluminium oxide, so it remains at the bottom of the crucible. There is an opening at the bottom of the crucible from where this molten iron is poured at the required plates where we want to create joint. This is basic principle of thermite welding. C. Extraction of less reactive metals. The bottom of the reactivity series of metals are less reactive. That is why they are found in free state in nature. For example, gold, silver, platinum. The reserves of copper in free state are very few. Presently, copper is found mainly in the form of Cu2s. Copper is obtained from Cu2s ore just by heating in air. 2 Cu2s plus 3 O2 gives 2 Cu2O plus 2 SO2 gas. 2 Cu2O plus Cu2s gives 6 Cu plus SO2 gas. Collect information. Collect the information regarding how mercury is extracted from its ore, cinnabar, and write the corresponding chemical reaction. When it is heated in air, it is first converted into mercuric oxide, HgO. Mercuric oxide is then reduced to mercury on further heating. 2HgS solid plus 3O2 gas upon heating gives 2HgO solid plus 2SO2 gas. 2HgO solid upon heating gives 2Hg liquid plus O2 gas. Refining of metals. Metals obtained by the various reduction processes described above are not very pure. They contain impurities. The impurities need to be separated to obtain pure metal. Electrolysis method is used to obtain pure metals from impure metals. Corrosion of metals. Can you recall what is meant by corrosion? Corrosion is the deterioration of a metal as a result of chemical reactions between it and the surrounding environment. Have you seen the following things? Old iron bars of buildings, copper vessels not cleaned for long time, silver ornaments or idols exposed to air for long time, old abandoned vehicles fit to be thrown away. Think about it. 1. Why do silver articles turn blackish while copper vessels turn greenish on keeping in air for a long time? Answer. Silver reacts with hydrogen sulfide present in atmosphere to form silver sulfide, which forms a black layer on the articles. The chemical reaction is 2Ag solid plus H2S gas gives Ag2S solid plus H2 gas. Similarly, when copper comes in contact with moist air, it forms green-colored copper carbonate. Hence, copper vessels turn greenish on keeping in air for a long time. The chemical reaction is 2Cu plus CO2 plus O2 plus H2O gives CuCO3 plus CuOH twice. Both are the examples of corrosion of metals. 2. Why do pure gold and platinum always glitter? Answer. Pure gold and platinum always glitter due to its lustrous property, and also those are less reactive metals. They do not react with air or water, hence no layer of oxides, sulfides are formed on it, hence they always glitter. Rusting of iron articles causes large financial